Thank you for joining me in this video covering setup and survey fundamentals. In this video, we will be covering three very basic survey principles that will help you avoid errors in measurements and setups that will save you time, money, and rework both on the decks during install and in chipping after concrete is poured. The setup methods can all be accessed through the three principal layout methods of layout points, layout lines, and as-built. Once a setup has been successfully completed, the setup applies for all three programs, meaning that I can switch from layout points to layout lines or as-built and continue working with the same setup. The button is found in the same location in all three programs and functions the same way in each. Since layout points is one of the most used of the three layout functions, I'll use this program for the purposes of this video. From within layout points, click on the setup icon located to the right of the toolbox in the lower middle part of the screen. The next screen will be the setup device page where you will be able to choose from up to 8 different methods of setup depending on the icon software version your tablet is running. In the upper left corner, within the coordinates palette, you will find Anywhere. This is the method you will use almost exclusively. Over Known Point within Coordinates and Transfer Elevation within Elevations are two less used but still important methods that can be taught upon request. For now, I'll click Anywhere within Coordinates in the upper left corner. The next screen I will see is the digital level bubble. Level the instrument so that all three check marks turn green and the bubble is in the center of the crosshair. Leave the compensator toggled on. Then, in the upper right corner, click the blue dot. The next screen titled Setup Instrument Covers Settings. These should only be changed when necessary. Typically, you will just click the next blue button in the upper right corner to advance past this screen, but I will explain the functions here for informational purposes. Within Instrument Settings, the first row is Instrument Height. This should only be changed when laying out objects at specific elevations based off known reference elevations. The height of the instrument is measured from the laser dot projected on the ground beneath the instrument up to the dot on the side of the instrument, representing the vertical center of the total station. Save Setup as Control Point allows you to store the coordinate of the point where the laser dot is hitting the ground beneath the instrument. This is useful if you would like to use this location as a reference target in the future, either to be measured with the prism rod or through setting up over known coordinate. To use this option, click in the box to the right. Beneath that is Code. This allows you to give the point to be stored a description. Generally, when I'm storing control points to be used in the future, I create a code such as New Control. This separates the point onto its own layer, which gives us the control over its visibility within the Layer Manager. See video 15 for a refresher on the Layer Manager. Let's quickly discuss creating and deleting codes. After clicking the Save Setup as Control Point box, click Code. The following screen is Select Code Definition. The only code now is No Codes. This is the default description for points that are stored or created in the sketching application that are not assigned a code. This No Codes description is also a layer which can be found under Jobs within the Layer Manager. Click the toolbox and Add to create a new code. Click in the name box and type in a name. Click the green check. You can click in the description box and type a description if the points you will be storing have certain aspects you would like to be described. It isn't necessary but may help if you are creating many points with the same code. Below that, you may select a different symbol which will make your new point stand out from other points. I advise using this method. I'll select one and then click the green check, which takes me back to the Setup Instrument page. Notice that the button to the right of Code has changed to contain the code I created. To remove that code, click the button to the right. If you wish to keep that code for future use, just click on No Codes so that the next points to be stored will be assigned that layer. If you want to edit any of your codes, click the arrow to the right of the code and make your changes. Then click the green check. To remove codes you've created, click the toolbox, Delete, select the code to be deleted, and green check. For now, I'm going to set everything back to the default mode. Next is reflector height under reflector settings. This is referring to the physical height you have the prism rod set to. Prism rod heights will be covered in hands-on training. The height is measured from the tip of the rod at the bottom to the center of the prism on top of the rod. This should only be changed in the tablet when laying out objects at specific elevations based off of known reference elevations. Next is automatic check setup. If you click the box to the right of prompt for check setup and then set a time interval in the box to the right of check time and hours, you will be prompted at those time intervals to perform a setup check. When prompted, you have the option to perform it or not. Best practice when laying out for a long period of time is to check your total station's levelness and remeasure one of your reference targets at regular intervals, whether you've received any error messages or not. I typically check mine about every 30 minutes, whether I've received any prompts or not. There are many factors that cause the total station to lose setup integrity through the course of the day, and it should be consistently checked and reset to maintain high layout quality. A few examples of these factors are vibrations in the deck, the crane turning with a load, the crane setting loads on the deck, high-rise buildings leaning towards the sun, heavy wind, people working near the total station, and human error. At this point, it's important to mention that if you notice a high volume of people working near your setup, you need to pay special attention to your total station. Even if it's set up on a deckmate or column clamp pod, which ensures it won't get knocked over, it can still be knocked out of level. If you ever receive a message saying that your measurement is not possible because the total station is out of level, you must fix your level and complete another setup anywhere by measuring your reference control points. Never adjust your level and go straight back to laying out points. Do not just ignore the error saying that measurement is not possible because the total station is out of level. What happens when a total station loses its levelness is that the center of the total station has physically moved off its axes, both vertically and horizontally. This not only affects the horizontal distances measured between points, but the angles between each point and the building as well, because the total station's base rotation angle has moved. It is very simple to avoid these errors. Just re-level your total station and complete another setup anywhere by measuring your reference targets again. You may have to do this several times throughout the course of the day, but this will absolutely save you time and money in the long run. If you mistakenly continue laying out without following these instructions, you will find errors later, and not only will you have to lay those points out again, but if your ITR crew has been installing right behind you, they will have to pull all the components they installed and reinstall them. If you don't catch the errors before concrete is poured, you will be chipping concrete later. Also, at break and lunch, you should always put the total station in its box, and when you return, you should complete a new setup anywhere. Digitally, the tablet does remember its last setup used before break or lunch, but the center axis of the total station has changed both vertically and horizontally. Never put the total station back and just start laying out points. It is important to choose your setup location wisely when you begin your day. Some factors to consider are volume of work in the area, so try to set up away from where people are working when possible. Movements of the building, so try to set away from the crane tiebacks, and try to set up near strong vertical members when possible, such as columns or shear walls. And location. Be sure that you can see your control points that you're going to use for your setup and as much of your layout area as possible to avoid large numbers of setups. Let's pick up where we left off. Again, typically you won't make any changes to the Setup Instrument screen. Clicking the blue button in the upper right corner takes us to the Setup Anywhere map view. Here, we're prompted to select and measure the first point. Setup Anywhere requires a minimum of 2 points measured. You may measure more than 2 points to strengthen your station's coordinate value, which further reduces opportunities for error, but you cannot measure less. At this point, I will switch to some PDFs I've created so we can go over some basic survey principles that affect the control points you choose to measure, the order you will measure them in, and the methods of measuring those points. The first example shown is regarding the distances from the total station to the control points, and the points to be laid out. After selecting the control point to be measured, we walk to that point with the prism rod and have the total station search for and lock on the prism. Then we measure and store the first point. During the process of measuring and storing, we must level the rod so that the bubble is precisely in the center. Field conditions often affect our ability to be precisely level when we click the Store button. For example, a wind gust, the prism rod out of calibration, or a crane load hitting the deck when I'm storing my measurement. As a hypothetical situation, as shown in the PDF, Let's say I thought I was level, but truly I was out by 1/8 of an inch. In the example of the proper setup method where my control point is further away than my layout points, you can see that as I move closer to the total station, the 1/8 inch of angular error caused by not being level is reducing. In the example of the improper setup method, I'm measuring my control point closer to the total station than my layout points, and as you can see, the angle error compounds the further away from the total station I move. This will cause that error to spread among every point I lay out in increasingly larger increments. The second example shown is regarding what's known as strength of figures. The basic principle is referring to triangulation used in land surveying, but we're going to keep this simple. When you're choosing the location to set up your total station and you're looking for your control points on the deck, try to pick a place where the angle between the 2 points when viewed from the total station is as open as possible, preferably between 90 and 179 degrees. This would be my total station. This would be my control point. The angle between them is greater than 90 degrees. The way the total station triangulates its location is by measuring the distance to at least 2 known coordinates and the degree of horizontal angle right turned between those coordinates. The total station establishes its base angle of rotation on the first point measured. So the first example of choosing a control point farther away from the total station than the points to be laid out applies to the first point measured. The second control point measured can be closer to the total station, but the further away, the stronger the setup coordinates will be. The third example reaffirms this. On the left is an improper setup method. From the total station's point of view here, the angle between the 2 control points is very narrow. The distances measured to the 2 control points create large overlapping arc without a clear intersection. This leaves room for numerous arc intersections that could shift your measurements. On the right is the proper setup method where the angle viewed from the total station to the 2 control points is very wide. As you can see, the resulting arcs created by measuring the distances to the points intersect in a very clear, distinct location. That intersection is the coordinate where your total station is set up, and there is a negligible chance for error in the coordinate value. Adding more than 2 control points to your setup anywhere creates more intersecting arcs, which helps the survey software more clearly identify the intersection. To summarize briefly, in a proper setup, choose 2 control points that create a wide angle when viewed from behind the total station. Measure your furthest point first, and make sure that it's further away than the points that you're going to be laying out. So let's select our first point to be measured as prompted by the software. You will know when you have a point selected because on the map it will turn blue, and in the upper right corner the ID box will be populated with the point number. A common error encountered is the selection of an incorrect point. Be sure that the point you select is the point you are about to measure in the field. By this time, it is assumed you know which point it is and have already walked over to it. Using Move and Search, you will want to ensure the total station is locked on the prism before clicking Start. Once lock is gained, click Start to begin measuring. At this point, ensure that the tip of your rod is precisely on the intersection of the control lines and your prism rod is level. Then click Store. The measurement is not recorded and will not be applied to the setup until you click Store. You'll know you click Store because the point you measured will turn orange and the prompt in the upper right corner will ask you to select and measure second point. I'll select a second point on my simulator, and as you can see, I can tell when I've selected a point because it turns blue and in the upper right corner of the ID box is populated. Notice that the Store button is still available in the lower right corner of my screen. For you in the field, it will look the same unless your total station loses sight of the prism. This is not a problem. Walk to your next point to be measured and reacquire lock through the move and search commands. Repeat the same steps as the first point and click Store. In the upper right corner of the screen, you will be prompted whether the calculated station is within or without of tolerance. Mine is out of tolerance because I didn't move my prism on the simulator when I stored. You'll notice in the lower left corner of the screen that a green ribbon has appeared next to the red X. Clicking this will show you the results of your measurements. At the results screen, you have several options. Typically, the most common reason for a setup to be out of tolerance is because the software recorded the elevations of your rod when you stored the measurements, even if you weren't using elevations for your setup. If that's the case, on the right side of the screen, below elevation residuals, you will see red X's instead of green circles. Click the red X's and it will disregard the elevation, which will allow you to accept the setup and proceed with your layout. If your horizontal residuals are out of tolerance, you have a couple options here as well. In my case, the horizontal residuals are out of tolerance because I didn't move the prism before clicking Store. I have two red X's and the amount of mismeasurement between the points. First, make sure you measure those points with the correct prism type. You should be using the MPR 122. If you had the incorrect prism type, click on the box and set it to the correct type. If your prism type was correct, another option is to measure a third point and then check the residuals. If they are within tolerance, you may accept the setup. If one measurement is still out, you may uncheck the box to the left of the faulty point. Yet another option is to remeasure the points. By clicking the red X, I'm taken back to the map view screen where I can select one of the points I already measured if I want to remeasure it. I'll be asked if I want to discard the old measurement and remeasure it. Click OK. Then you'll be asked if you want the total station to automatically turn to where it thinks that point should be. I always click Cancel because I want to maintain lock on my prism. Then remeasure and store the point to see if your residuals improve. If you are still out of tolerance, check the levelness of your total station and remeasure while ensuring that you have the correct points chosen as your targets, your rod is precisely level, and the tip is precisely on the intersection of the control points. If you've done everything correctly and you're still out of tolerance, take a tape measure and check the distance between the control lines to make sure the concrete layout team laid out the control lines properly. You can also use the checks program, which will be covered in a future video, to extract the dimension from control lines to hard objects such as walls or columns, and then use your tape measure to check those dimensions and see if they're lining up. If you find control lines laid out incorrectly, kindly let the concrete layout team know what you found and show them the dimensions you checked to the columns and walls. Then use a different target for your setup. Once your horizontal residuals are within tolerance, click the green check. When you are returned to the map view, you will notice another green check next to the green ribbon. Clicking the green check here will accept the stored measurements and establish the coordinates and base angle of the total station. You may click OK at the next prompt accepting this total station setup. You will then be taken back to the Layout Points map view where you are prompted to select a point to stake out. To summarize, 3 important keys to choosing your control points. Make sure the control points to be measured are further away than your farthest point that needs to be laid out. Make sure you measure the farthest control point away from the total station before the closer one. Make sure the angle between your two control points is between 90 and 179 degrees. This concludes the Setup and Survey Fundamentals video. Please continue to the next video that will be covering layout points.